Ladies and gentlemen, welcome to this presentation of Edgecam 2010 Release 1. Today we're going to be seeing solids machining and our 5-axis machining centre. During this particular demonstration you'll notice how Edgecam keeps its toolpath associative always to the solid model. We're also going to be using automatic feature recognition, whereas the toolpath, in this case 2.5 and 5-axis simultaneous toolpaths, we can guarantee our gouge-free machining onto those features. This will maximise your profits, and of course we can do this by minimising your downtime. So let's begin the demonstration. Here we can see the solid model and material, raw material, mounted onto a fixture plate on a DMU 5-axis mutated table machining centre. Our first task is to try and move the weight of the material. With a roughing operation, we digitise directly onto the solid model, and now using an interactive dialogue operation, Edgecam begins to produce its CAM toolpath. We go through our tool store, selecting an appropriate tool. At the click of a button, we can see that we'll now get our toolpath. Edgecam always employs an interactive dialogue box, as a picture speaks 1,000 words, and this is the quickest and fastest way of learning our CAM system. Your return on investment is almost instantaneous. We're now going to update the stock. The solid model is always updated, guaranteeing that we've got no fresh air cutting. We're always making sure the toolpath is in contact with the material. We now produce a further 5-axis swarf operation. Swarf operation side wall axial relief feed. 5-axis profiling cycle, and again this very complex machining pattern is achieved by an operation. Notice how the tool now will machine tapering inwards to the sidewall, and the tool path, knowing that it's been already produced and safe and gouge free, is copied down, and the machining toolpath is transferred to the opposite feature. A third swarf operation is also created. This again, as you can see, leans the flank of the cutter into the component. Lastly, in terms of 5-axis simultaneous machining, we're going to use a blend between curves operation. The very complex outside curves need to be machined to greater accuracy. Again, you can see the interactive dialog box is being used, prompting and helping the user understand exactly how they will influence the toolpath. Again, the tool is chosen from the tool store, and with great confidence the user can now proceed ahead, guaranteeing that they have the right sort of toolpath. We guarantee 0 collisions in our software. This is because we can check the toolpaths in what we see now, Edgecam Machine Tool Simulator. Not only can we check the kinematics of the machine tool, but we can check for holder collision against the stock, tool collision against the components. As we can see now, the toolpath is beginning to generate out a rough toolpath. Now we're ready for our 5-axis machining. The ball nose cutter is presented to the feature, and the mutated table swings into position, allowing the tool to produce a tapering sidewall, a swarf cut. A further swarf cut is taken down the sidewall, thus guaranteeing maximum efficiency, as we don't have to constant cusp down the sidewall. Traditional slice machining is a lot slower compared to 5-axis machining. Again, for complete confidence and peace of mind, the user can manipulate the view as much as he or she likes to make sure they can see all the way around the component, thus buying that confidence for when we produce our toolpath. We now turn our attention to positional machining. The pockets and the holes around the outside need to be machined. We index the tool in the style of G54 and the extended work offsets, indexing the tool into position. We can see now clearly that the tool is pointing in the right direction, and using the automatic feature recognition, the feature is selected and Edgecam offers, in this particular case, 4 different machining operations. A roughing operation is instantly executed onto the pocket, and again the user simulates to make sure that the tool paths are completely collision free. A second index move is now used to move us around to the second pocket. This would instigate a B60 or an A90 degree move on the component. Again, the user can completely see that the tool is clear and is free now to enter into the pocket area. And yet again, using the automatic features, the same roughing command is used, using the interactive dialog box, and a tool path is further produced. This method guarantees consistent toolpath and consistent accuracy. Once the toolpath has been produced, we can now produce a hole drilling operation. The user just simply digitizes each individual hole feature around the component. It doesn't matter to Edgecam if these features are on different angles. Edgecam will automatically index its way around the component, finding the right sort of tools. Now we can see Edgecam automatically picks up the drills and the taps, all being brought in from the solid model. Edgecam actually chooses those tools because it sees the feature character from the solid model. We now see the drilling command, the countersinking command, and furthermore we will see the last command in this particular area, which is a tapping command. Finally, just for guaranteed peace of mind, we once again enter the machine simulator. Because we've already seen the component being machined, we can change our stop options and fast forward to the relevant area of the toolpath. In this case, we can see fast forward now taking place, and Edgecam will jump on tool by tool until we've got to the area where we're interested in. In this case, it's the 3+2 indexing or multiplaning around this particular component. Again, we're not only checking for gouge-free toolpath, but we're also making sure that this very expensive machine tool is not in collision with either itself or the fixture or the toolpath. And again, we guarantee to our customers gouge-free machining. When this customer produces his CNC tape, he has the peace of mind of knowing there will be 0 gouges. I hope you've enjoyed today's demonstration, and please contact Planet for more information. Thank you.